Chi-Wen.
Yes, I can hear.
Oh, okay. Very clear your voice. Okay.
It's okay right now.
Okay. Thank you, Prof. Maybe we can start the class. Yeah. We
Okay.
have a moderator, Master of Ceremony, Miss Tania. Please to start this class. Thank you, Miss Tania.
Okay. Good afternoon, everyone, all speakers and participants. Welcome to day one of CAS Lecture 2021, held by Information Systems Universitas Airlangga. If you don't know me, my name is Tania, and I'm an Information Systems student in Universitas Airlangga. I'll gladly be your MC for today until the end of the event. Before we start, I'd like to give you a brief of what we'll be doing today. The class will start with an introduction. We'll get there soon right away after this, which will be followed by the main session, the CAS lecture. As you might have known, the topic for today is titled From Industrial Design to Biomedical Informatics. Please kindly refrain from unmuting yourself during this session. After the lecture ends, you're allowed to ask any questions related to the lecture to the lecturer today, that is Associate Professor Long. You may either drop the question in Zoom's chat box or raise your hand virtually before unmuting yourself when given the chance. You may ask in Indonesian, as I'll help translating it to English, but raising the question in English is preferred. After the Q&A session, we'll have a small photo session to record the memory in frames, and in this session, all participants who don't mind to turn on their cameras are encouraged to do so. If you need a certificate as a token of attendance, please kindly fill out the feedback form, whose link will be sent to the chat box later by the end of the event. If you have filled it out properly, rest assured that the certificate will be sent to your email inbox in less than 24 hours. Okay, now that we've briefed the rundown, let us all hear a foreword from our head of major of information systems and our biomedical informatics teacher, Mahendra. The time is yours.
Okay, thank you, Miss Tania. Good afternoon, everyone. Good afternoon, Prof. Lung. Thank you very much for your willingness to give a guest lecture today. It is an honor for us. We hope my students could gain new knowledge and insights from your presentation today. We are very happy and very glad to can meet with you today. Thank you very much. Okay, Ms. Tania, please continue.
Thank you, Mahendra. Before we go with our main session of the day, I'd like to introduce you to our speaker, a Bachelor in Industrial Design and a Doctor of Philosophy in Biomedical Engineering, and also an affiliate of Department of Bioinformatics and Medical Engineer at the Asia University, all the way from Taiwan, comes Associate Professor Lung Chi-Wen. The time is yours, Professor.
Okay, so my turn, right?
Yes, right.
Okay, so thank you, Professor, for your introduction, and I'm very glad to join today's meeting. And I think I'm very glad to share my experience and my study for every student and the college and the professor. So right now I try to share my screen, and if you have any question, please let me know. For example, you cannot see that. Okay, you cannot hear the video. Please let me know. So I want to share my screen. Okay. Okay, so all of you can see the screen, right? It's okay?
Yes, sir.
Okay, okay.
Yes, sir.
So my topic is from the industrial design to the biomedical informatics. Why I tell you, why I want to say this topic, just because you can see my my working department, and one is the creative product design, another is the bioinformatics and medical engineering. So that is why I am focused on the design and the biomedical informatics. Today I want to introduce about the 5 topic. Of course, that's the one is the question and the answers. And from the beginning, I want to tell my background first and my interesting field. And then I want to introduce my previous studies. But right now, I don't want to one paper by one paper to introduce it. I just want to introduce part of the concept, because after you know the concept, you will know my my knowledge and my why I want to do this study. And I want in the last one, I also want to show my current study. Okay, so first is the biographic. That is my background. So this is my lab name. I call it is the biodesign. Why? Because the biomedical or industrial design, so we can combine both of it together. Actually, the same name will also can be found in the Harvard University. So I hope our study will be better, will be similar type near with the Harvard University in United States. Okay, here is our campus, and our lab member is this guy. We also right now we have the PhD student and the master student, and let me introduce them. First is Peter. Peter is the left guy. He's from the Indonesia. His background is the visual communication design, so that is the very different with you, right? And his university is in the Semarang in Indonesia. And the second one is the Funny. Funny is his background is nursing, and he is from the Yogyakarta, UMY. That is also different. The third one is the Sunati. His background is the mechanical engineering. He's also from the Yogyakarta, UMY. And the fourth guy is the White. He is a medical doctor and from the Germany. Actually, he just stay here. He just
谢谢。Maybe his signal disconnected. Terputus ya, Cok ya?
Iya, Pak. Terputus kayaknya.
Iya. Kita tunggu aja. Saya udah kasih tahu kok. Your seat-nya disconnected. Switching. Iya, keluar ya sinyalnya ya. Ya, mohon ditunggu saudara-saudara. Nah, mungkin nggak tahu masalahnya di sebelah mana, di awan yang sebelah mana nih. Nah, ini, oke, dia udah baca. Belum, masih berusaha connect. Presensinya udah disiapkan atau gimana, Cok? Presensinya?
Udah siap linknya.
Oh,
Nanti pas akhir kelas.
Oke. Oke, iya udah join lagi, Prof. Lung. Oke, udah join. Welcome, Prof. Lung. Okay.
So let me back again. Okay, sorry. I have a trouble. The connect is not well. So I want to share my screen again. Sorry. Okay, it's okay.
Okay, Prof.
Yes, Prof.
Okay, so I continue my presentation. Okay. If you have any questions, please let me know. And because I didn't after if Professor Hendering, you also Hendry, you can also can lie to me and let me know. My line is still open. Okay. Okay. So I want to continue my presentation. So here, this guy is White. He is the medical doctor from the Germany, and this guy is from the Taiwan, and this guy is from China. So all of our lab member is from different country. So in our lab, office language in our lab is the English. So people need to co-worker, so they try to let the office to be the international. Okay, so right now I want to introduce our campus and our lab. Wait a minute. Okay, that's okay. I will show it.
Hello, my name is Veit. I'm a medical doctor from Germany and came here to the Asia University 6 months ago to join the Department of Creative Product Design for Research in Biomedical Engineering. I had an incredible time here and would like to show you this beautiful place and what I did here. Due to the recent COVID outbreak, everything is closed and empty right now, so I'll use my new drone to show you the campus from outside. We will start at a dorm where I lived for the past couple of months. Let's go! Here we have a good view on the dorm and the volleyball fields. Usually this is full of life and people. A good analogy for my time here lies in the rice fields, because when I came, the plants were small and green, and now a good portion of it is already harvested. In the distance, we can see the Asia University Hospital, where I learned the fundamentals of Chinese medicine, something I will always keep in mind throughout my professional career as a doctor. But the hospital is the wrong direction, so we have to turn around. Here is the football field. That's also very useful to learn how to fly the drone. And the university gym. Here I took a better picture. So we enter the campus via the main road, straight onto the roundabout. This is the beautiful modern arts museum where I like to spend my time. From the dorm, you only have to cross the road to enter the rest of the buildings. In this building, I had my weekly Mandarin class. And here you can see the park in the middle. From my own experience, I can tell you that these stairs are ideal to hang out in the evening with your friends from all over the world. One of my favorite spots. And we are already through the main building. Here's a nice park area with ponds and trees. And next to the main building, you can see the manufacturing workshop with lots of cool tools that I happily visited whenever I could. And behind it, maybe there's a possibility to peek inside the main building. Success! Luckily, we are very close to the research lab where I spend most of my time. It's a good opportunity to give you a small glimpse on what I did here and generally during my time in Taiwan. Using state-of-the-art ultrasound devices to measure tissue health and preventing future complications like diabetic foot ulcer. Building devices to analyze the properties of biomedical materials and doing other biomedical experiments. Having fun with robots, but also teaching about robotics. Lots of 3D printing, traveling the country to attend educational events, giving speeches at other universities, and learning about Chinese medicine, as well as meeting interesting people. The only negative part about my time here is that it's already coming to an end, as I would like to stay here longer and finish my projects.
Okay, so here is the video and wait, I don't know how to close it. Okay, so back to our slide. So I want to say about the 2 or 1 years ago, and Airlangga have the 2 students in our lab. One is Aku, another is Rent. So after they finish their programs, they also have make a video. Let me see. I try to. No, it's also not working. So I need to back to the video player.
Hello, my name is Aku Anastian. You can call me Aku. I am from undergraduate student of Information System in Universitas Airlangga, Surabaya, Indonesia.
Hello, my name is Renaldi. We are come to Taiwan to join Taiwan Experience Education Program 2019. And now we work at a bio laboratory at Creative Product Design Department, College of Creative Design.
My research was about I make a prototype device. It's called Subcribe. I make this device to help a nurse to determine for the time replacing of the medicine liquid, and this device is based on Internet of Things. I just combine this device of the Arduino, load cell, and also Wi-Fi.
My research was about to build a management system for the hospital. I'm already made a database that integrate with hospital system and also Subcribe. My second research is about artificial intelligence in medical imaging.
I learned many things in here from my other student, also my professor, Professor Chi-Wen. I learned new things here like software programming, like MATLAB, LabVIEW, artificial intelligence, image processing, signal processing, and many things. And we also learn about the research course, like how to make a journal, how to make a review paper, and also meta-analysis. And in here, we learn also about the design, because we are in a department of creative product design, and also we learn how to operate the lab's instrument that was very expensive, like 3D printing, 3D scanner, text scan, artificial intelligence computer, computer server, and the other.
We were very excited that we have an opportunity to get an internship here. Taiwan is a good and beautiful country. I already visit many times in Taipei, Kaohsiung, and also Taichung. We visit many places like Taipei 101, National Chai Kai-shek, Memorial Hall, Kaohsiung Zoo, and the others. And for your information, Taiwanese food is very delicious. I love it.
We did many activities here because we have so many Indonesian students in here, and we go outside together, we playing together, playing badminton, we also cooking together, and we also riding a bike.
This is the first winter season for us, and we have a new experience to know how the weather is. It's very good. And then we also get a new friend, and besides that, we have learned many things, such as culture, rules in Taiwan, and also Mandarin language.
Taiwanese people are very kind. When we have any difficulties, my friend in here and also my professor always support us. We are very happy in here. In here, it's like a new family for us. Thank you for everything.
Okay, so after both video, I think everyone will know my laboratory and our campus. So right now I will after almost about a half hour, right now I try to introduce my topics in the industrial design to the biomedical informatics. And this is my background. Actually, I before the master degree, I always focus on the industrial design, and the training is let me know the what is a problem and how can I find the solution. This is my training. That is industrial design, because the industrial design focus on the how is the people want to use the and what is their need, and we need to find a good solution for this consumer. And but in after the I get the master when I go to the when I was a master student, and in that time I focus on the shoe design. In the shoe design, as we know, lot of the different brand, for example, like the Nike, Adidas, or others. This shoes is a big shoes company. This big shoe company should be have the lot of the biomechanical lab. Why? Because they want to get the good wearing. So how and where the shoes is comfortable. So how can we let where the wearing is comfortable? So that is basically on lot of the science technology. For example, like the pressure, skin, soft tissues, and like the blood vessel, perfusion velocity, and a lot of this science technology. So after that, when I go to the PhD, I focus on the biomedical engineering. So this the biomedical engineering, they have the three topic. The first is the electric. Second one is the mechanical. The third one is the chemistry. So because my background is industrial design, so I chose the mechanics. So in the biomechanics in this field, I learned a lot of the device, instrument, and how to do the data analysis. And finally, I graduate. Then I go to get the find a job. My first job is for the shoes company. The second one is the Taipei government. The third one is Biofosun. The Biofosun is focused on the let me show. Sorry. Let me show it, because if I have laser point, that is a bit better. Here, this guy, wait a minute. Okay, here, yes, good. Here is a biophoton. Biophoton is the focus on the in the medical instrument development. So we design it, we make it, and we sell it. That is biophoton. So after that, I go to the after about 2 years or 3 years, and I back to Taiwan. Here is in China. Here is in China. After 3 years, I back to Asian University, and in that time, I'll also be the visiting scholar in the Oklahoma University and go to the UIUC University of the Illinois at Urbana and Champaign. And this is my learning and working experience. So in the about the industrial design, I make a lot of the instrument. For example, the shoes, and this is smart shoes. Smart shoes is focused on the smart shoes is what it can they just embed the sensor, the pressure sensor on it, and we can measure the pressure sensor and the link with your smartphone, and a lot of information can get from it. Another is about the working. Like this one. This is the force plate. This is about the we can measure a lot of the pressure or the force on the ground. And here is the drip system. A drip system just can allow for the nurse to let them to change the drip. This is for the hospital. Okay, after the biographic, and I want to tell you my interesting field. This is my study. That is same from the 1997. I get my master degree until to the 2020 right now. So I want to introduce it one by one. Okay, good. This one is for the plantar pressure. Plantar pressure, we just use the walking to detect the plantar pressure. And we also use the force plate to get the anterior posterior, and because we know we have the 3 dimensions. First is the vertical force. Another one is the anterior posterior force. Third one is for the medial lateral force. So the when the people walking, when the people working on here, and we can get this is one is a vertical force, anterior posterior force, medial lateral force, and here is the velocity. And after that, I interested about the soft tissue property. The soft tissue property, we use about the Young's modulus. I will let you know later. And then I focus on the ultrasound. Why? Because the ultrasound, we can detect the thickness between the skin and the bone. Here, okay, I cannot. Here is the skin, and here is bone. So here is soft tissue. The soft tissue property, we can use the ultrasound to detect it. And then I focus on about the soft tissue injury. For the spinal cord injury, spinal cord injury, people need to use the wheelchair, and in that time, sometimes his button, because when they wear the wheelchair, this guy is sitting on it. His button also have the trauma. So I want to try to figure out what happened, and then to make some suggestion to let me prevent this risk. So then I back to use this method on the diabetic foot. The foot is also have the trauma and then amputee. So we try to use the same concept to prevent this risk. So then I also use the wheelchair. Wheelchair is about joystick. Joystick is we want to use the artificial intelligence to control the wheelchair joystick. And here is about the ultrasound. Then right now we focus on the elastography. Elastography, that is the elastic with the ultrasound. So this is, until now, we always focus on the artificial intelligence. This is recently 2019, I tried to learning about artificial intelligence. So this is all my study right now. So first, I want to introduce because I know lots of the student, his background is not master or a PhD. So I just used a very simple study, because this study is my master dissertation. This is very easy to let all of you to know what is biomechanics. Okay. We know this is foot. Foot, we can divide about the 3 parts to get the arch index. What is arch index? If we over the 2.3, that over the 2.3, that is about the flat foot. If we minus the 2.1, that is about the high arch. And we also can divide this foot into lots of a region. So people is walking on the ground, and we can use the plate pressure system to get the plantar pressure. In this time, we just want to know how is the turn type different with the normal walking. So then we will get the plantar pressure like this one. Okay, so we are also interested about the go up or go down the stair. That is how it's different with them. Because why I want to do this? Because sometimes the skin trauma will also happen in this situation. So when they are walking on the stair, that would be the high risk. So I want to know it. Then we also get the result. And we also try to use the insole material property, because that is very easy to get it. First is density. Density is the mass divided to the volume. This is very easy to detect it. This is also easy to, because when I was the master program, that is the industrial design. So we don't have the high technology instrument. So we use the very easy to do that, to get the coefficient restitution. So use the camera, and you can easy to get it. And this is jump. And when the ball jump on the material, when they we can easy to use the equation to get the coefficient of the restitution. Okay, that is the density about these 4 material, the property, how it's different. Okay, so we use the 4 material. We use this 4 material to wear the shoes and use the insole pressure system. We get the result like this one. Okay, so above is just try to use the different material. First, we know the problem, the walking, the turn type, turn right, turn left, or the go downstairs, go upstairs, and try to know how it's different. And then we use the material, insole material, to try to decrease the plantar pressure. That is my master dissertation. And right now, I want to introduce my PhD dissertation. My PhD dissertation is focused on the food structure morphologies on the plantar parameter measurement. What is that? That is the flat foot, normal foot, and high arch. For example, this guy is the normal foot, and if they without this one, this is the about the flat foot or high arch. Okay, so the main important is about the middle foot. Before that, I want to introduce about the heel rock. The heel rock is about the heel rock model. Sorry, rock model. The rock model have the three. One is the heel rocker. Second is the ankle rocker. Third is the full rocker. What is that? That is for when I was working. Here is the initial contactor, and here is about the ankle rock, and here is about use the full rocker. So these three rocker, we can use the ground reaction force to get the center of pressure to detect it. The heel rock, ankle rock, and the full rock. Okay. Then I use the procedure to do it. First, we use the scanner, just the scanner, the office device, the scanner that you can use it in your office. Put your foot on it and scan it, and then we can easy to detect the arch index Q1, Q2. For example, that this one is a flat foot, this one is high arch, and then we use the radiographic. The radiographic, we take the three sagittal, frontal, and three transverse, three view to detect it. Then we mark it. We mark all of the bone, and we do the model. Then after that, we know the full axis, the bone axis. Actually, that is bone axis. The bone axis, we can calculate the angle. For example, this is calcaneus and the first metatarsal angle. This is the talar and the first metatarsal angle. And then we can make a correlation between the scanner and the X-ray. So this is the calcaneus and the first metatarsal angle between the scanner. So after that, we will know the arch index is working or not, because the X-ray is the more precise, is better. Is the medical data always know it. If the correlation is very well, then in the future we can use the scanner to detect your bone axis. That is what I want to do. And the second one is about the bone alignment. And this because we get the center of pressure, so we will know the duration is totally different. For example, you can see that is the shorter, that is wider, and how is the different. So we use that of the previous reference to support our finding. And here is, you can see the left one is the flat foot. This one is about the normal foot. This one is a high arch. So totally, oh, sorry, this is high arch. It is normal. This is flat foot. So after that, we will know the difference. You will see the flat foot is always in the middle, and the high arch in here, they have a wider. So after that, we will see how it's different with the center of pressure. Okay, this one is center pressure. You can see in the left. This one is the center pressure. They have the, see like this one. Okay. So then we have the pressure data. Then we can try to detect the different foot region, different plantar region pressure. You can see the high arch. Here is high arch. Here is normal. Here is the flat. Here is a flat. So that is the total different with the result. Okay. So about the ground truth force, we also can detect the different result. Okay, this is about high arch, normal and flat foot. Okay. So after I have this background, then I can try to use this one to get the my research and publish it. And here is I just use the scope to find the subject area. Actually, after that, I do lot of it, and they give us the like this one for the gate analysis to the from the foot gate analysis to the foot soft tissue, and then go to the plantar pressure, then go to the soft tissue property. So that is, sorry, wait a minute. My mouse is not working. Okay, so go to, sorry, back to here. So go to the analysis, then go to the plantar ulcer, pressure ulcer, and then go to the soft tissue property. So that is why right now my four major topic is in here. So actually, this is the scope give us the subject area. Actually, the main point is engineering, computer science, medicine, mathematics, neuroscience, and the healthy profession. So let me tell you my principle, my main concept. First is Young's modules. Okay, I will maybe some people didn't forget it, but when you are a junior high schooler, you also have learning about the Hooke's law. I will tell you what is Young's modules. Young's modules is just to for the force and the displacement. For a long time ago, you have the about the spring, right? The spring have the weight, and they have can length it, and the delta L, sorry, here delta L, and here is about the here is the loading, here is the weight and the delta L, that is Hooke's law, and the Young's modules is also like that. I will show you the video. Let me do that.
Welcome back to the Efficient Engineer channel, everyone. Let's introduce Young's modulus using the tensile test. The tensile test is a very common mechanical test, which takes a test piece and stretches it along its length. It is a uniaxial test, meaning that it applies a load in one direction only, as shown here. During the test machine measures the applied load and the change in length of the test piece. The main output from the tensile test is the stress-strain curve, which describes how much the material we're testing will deform for different levels of applied stress. Watch how the stress-strain curve evolves as we perform a tensile test on our test piece, which in this case is made of steel. The test ends when the material fractures. We can observe that the stress-strain curve is split into two regions, the elastic region, where the curve is linear, and the plastic region. If the applied stress is low and we remain in the elastic region, the original dimensions of the component will be completely recovered when the applied load is removed. For larger stresses that take us into the plastic region, Permanent plastic deformation will remain after the applied load is removed. In the elastic region, the stress strain curve is a straight line for most materials. This means the strain is proportional to the applied stress. Hooke's law gives us the relationship between stress and strain in this linear elastic region. The ratio between stress and strain is Young's modulus, also called the modulus of elasticity, which we denote with the letter E. It has the same units as stress, so PSI in US customary units and pascals in SI units. We can also measure Young's modulus as the gradient of the slope in the elastic region. Young's modulus is essentially a measure of how stiff a material is. The higher the Young's modulus, the stiffer a material, and so the smaller the elastic deformations will be for a given applied load. If we perform tensile tests for a few different materials, we will notice that the slope of the stress strain curve is different for each of them. Different materials can have vastly different values for Young's modulus. For anisotropic materials like wood or composites such as carbon fiber, the value of Young's modulus will depend on the direction in which the load is applied. This graph shows the range of typical Young's modulus values for polymers, metals, and ceramics. In general, ceramics have higher values of Young's modulus, metals have slightly lower values, and polymers have much lower values. Why is Young's modulus different for different materials? Understanding what is happening at the atomic level can give us a better understanding of Young's modulus. On an atomic level, a material's Young's modulus is closely related to the strength of the bonds between its atoms. We can imagine these interatomic bonds as tiny springs connecting adjacent atoms. Elastic strain is the result of an increase in spacing between the atoms of the material and is resisted by the strength of the interatomic bonds, or the stiffness of the little springs in our model. This is very different to the mechanism behind plastic deformation, which involves rearrangement of the position of the atoms.
Okay, so right now, everybody I think knows what is Young's modulus, but actually in our study we are focused on the soft tissue Young's modulus that we call that is about the effective Young's modulus. Effective Young's modulus that is modified by the Young's modulus. Why? Because the soft tissue is not different like the metal, like different like the plastic. Ceramic that is very different. So we try to use not use the strain. We use the compress. This is strain. This is compress. For the soft tissue, this is our bone. This is our tissue. So we use the loading on it. We use the compress, not the tensile on it. So this is our device, and we use the load cell to get the data. And see, you can see here is ultrasound. Here is load cell. Here is the motor unit. And the motor unit to push the ultrasound probe with the load cell into our skin. Then we can measure first, we can measure the force. Second, we can measure the thickness change of the soft tissue. Okay, after that, we can use the displacement and force to calculate the, as I said, effective Young's modulus. Okay. So, for example, this is like our first metatarsal head for in here. So we can see this is the left side. Left side is the ultrasound, the B mode image. Right side is the about the elastography. That is the ultrasound analysis result, elastography about the elastic. So after push unloading, loading, unloading, we have a lot of a cycle on it. Here is loading, and the force is increased, and the thickness will also decrease, and then we can get the result similar like this one. This is force. Here is force. Here is the thickness, the deep thickness, and this is A mode. This is ultrasound A mode, and then we can get to get the loading and unloading. Oh, okay. So loading and unloading. Here is the up, and here is down. So a soft tissue is totally different with the as I said, metal, plastic, ceramic, because we don't have the linear. We just have the curve in the initial and in the loading and unloading. Okay, this is first about the effective Young modules, the principle of one of my principle. The second one is the pressure gradient. The pressure gradient, the main important is everybody know when we working on it. When we working on it, we have the vertical force. Also, we also have the shear force, shear stress, shear force. So shear force is we can easy to use the instrument to detect it, but it is not complete it. Why? Because because for example, like this one, this is the shear force. Shear force. People on it, and they have loading on it, and we can measure this one force. So this is about the shear force device, but this is not, we cannot measure all over the foot because this only about the very small. So we try to use this one. We try to use the plantar pressure, and to detect the working pressure. Then we use the similar like this one, gradient. The pressure gradient, that is we can also easily watch in our weather forecast and weather forecaster, because that is the gradient is the very have the raining, have the wind or something, and high pressure, low pressure, their conjunction should be have the big storm something. So we can also use this one applied on our plantar pressure. For this one, we just use the similar use this one to get like this one gradient. If you can find, if you use the Google, you can easy to find it. That is gradient. Gradient, that is easy to detect it. So after that, we can use the gradient. Gradient just about the node by node, how it's different between the node and the node. Sorry, how is the pressure difference between the node? So you can easy to use it. And after that, the gradient we can apply it on our study. For example, this is the people's skin have the colors, like our foot have the colors. The colors is if we use the normal stress, or here in the colors, the shear they have a more shear stress on the colors. Okay. See, this is the pressure. This is average, but here is have a different gradient in here. And in here, we also can say it. This is our bone. This is our bone. This is our soft tissue, and this is a seat. And this is vessel. Sorry, this is vessel. Here is vessel. The vessel is normal velocity, but when we don't standing, when we standing, it is normal. But when we sit on it, here is bone, here is soft tissue, and here will decrease the blood vessel velocity or the perfusion, decrease the perfusion. And if the gradient in here, because this is unnormal distribution. So in this time, the perfusion velocity will decrease. So this is maybe this one is the more important for the ulcer injury in here. This is we applied this concept in the spinal cord injury. People use the wheelchair. Okay, here is another one, gradient angle. Let me introduce it for you. Gradient angle, that is our new concept. Actually, we have published this one into about 2 or 3 paper about use the gradient angle. Okay, here is the always we use the gradient in this one. But if we can the angle, if the angle is changed, so in the first second they apply in here, second they apply in here, third second they apply in here, nothing happened. But if he always in the first second, in the first second they apply in here, second apply in here, third second applied in here, so the angle didn't change. If the angle didn't change, they should be have the more high risk for the ulcer or trauma in this node. So that is my another concept is the gradient direction, or we can call that a direction angle. If the direction angle is always change, that is okay, no problem. But if they always focus on one node, they have a big mistake in here, big problem in here. Okay, here is the gradient angle. Okay, the last one is the blood velocity. The blood velocity is we use the LDF, laser Doppler phlebometry, to detect the blood vessel velocity, and then you can see the heating. When we heating about the 42 degree in here, 42 degree, then the velocity will increase. Here is blood flow, blood perfusion, that is velocity. They will increase. That will increase. So in this time, we will know if you are a diabetic foot, if you are diabetic mellitus, and you have the sick about the blood vessel, in this time this one is not higher. You will not as higher than similar with the healthy people. Maybe you will lower. That is the concept. In this time, we use the pressure sensor with what? We applied it in the rate in the animal test. And the animal test, we have a loading on it. Then we use the laser Doppler to detect how is different. For example, like this one, we applied the in here, in this area, in this area. So you can see in here we also have the black color. So that is we then we can silence it and get the data about the high risk of the injury, like this one. Okay. all, that is our, I use this concept to publish a lot of paper. And right now I want to introduce our current study. First is we still use the ultrasound to detect the plantar tissue property. But right now we try to use the other therapy for this one. We try to define, because you know the soft tissue have the two. One is the skin, another is the inner layer, and maybe the elastic is different. We can call that is E1 and the E0, or E0 is between this one, and the E1 is maybe in E1 is maybe in here. And the therapy is we use the air insole, because in my master dissertation I use the different material, but as you know, the Nike, the Adidas, they always use the air cushion, air insole. So right now I want to use the different inner pressure of the insole to detect which the inner pressure is better for the shoes, okay, for the material, for the soft tissue material, okay, property. So that is why I want to do right now. Okay, second one, I try to use the cupping therapy. The cupping therapy for people, they have the they use the cup to, this is a head, this is the body, and they use the cupping therapy to decrease the fatigue, muscle fatigue, to decrease the muscle fatigue. But the main important is heating. Right now we know the 42 is good. 42 is good for the people, but how is different? So I try to get the warm up normal in about the 27 degree and 42 degrees, and I want to try to know how is the effect for the muscle fatigue. We want to, actually I think the 22 is maybe better than the 27 degree. That is what I guessed. Third one, I use the artificial intelligence to classify the footprint. Actually, they have a lot of the footprint, but if we can use the deep learning to detect it, that would be better. Okay, this is about the artificial intelligence for the footprint classification, about the different walking speed, walking duration. If you walking slowly, the footprint should be different with the faster walking. That is my concept. So I want to use it to classify it. And this one is because foot have as we know, people have the toe out and the toe in. Here is toe in. Walking. If they walking toe out, and here this one is the toe out. This is normal. But if people walking is the toe in, that is not good. So I want to use the artificial intelligence to detect the foot axis. Sometimes the people maybe will like this one, toe in, and they will easy to fall in. So if we can do that, that is more convenient for the people to do that. And we also use the artificial intelligence to detect the spinal low back pain. The low back pain is the spinal have the total difference with the healthy people. So we want to use the artificial intelligence to detect it. So above is my study, and I want to let all of you to know that is the very interesting and exciting work for all of you, because if you have any question, then you can try to read the reference paper to find the solution. And maybe the one paper cannot help you. Maybe you can find another ones, or you can after you compare the both paper or other people study, then you can find a new solution. That is what I always said. The industrial design, the training is ask a student to find the good solution for the problem. Okay. This picture is about the 2 or 1 years ago. The Airlangga, your department, your division student be the Asian University, and we have the group photo. And I hope you will enjoy today's presentation. If you have any question, please, we can make a discussion right now. Thank you.
Thank you, Professor Long, for the insightful talk. Now we've reached the Q&A session. So if you have any questions, you're allowed to raise them in any minute now. Either you can drop it in the chat box, or just raise your hand virtually and you can ask Professor right away.
I think Professor Hendrody, you can ask first. No one, you can be the first people.
Okay, maybe my student same, yeah. Thank you very much for your nice presentation today. I will ask about the opportunity for my student if they want to take the master student. Is there a scholarship maybe from your university?
Yes, of course. Because we have the about the scholarship, we have the 3 level. The first level is you can get about, I guess, is about the, I didn't know how about to change it, but the US dollar is about the 1,000 US dollar per month. I think that is the best, the level 1. The second, the level 2 scholarship, the level 2 is without the tuition and without any about the and about the 500 US dollar, I guess, 500 US dollar. And the third one scholarship is without tuition and but without any scholarship. But yet, of course, they just don't have need to pay any tuition. So we have the 3 level stage. And beside our university scholarship, the Ministry of Education, that is more easy to get the scholarship, because in that time maybe about the 1,500 1,500 US dollar per 1 month. And actually you can get in the master degree, I think 2 year, the Ministry of Education scholarship for the PhD student, you can get about the 4 year. In that time, I think that is good for you, for all students to come to Taiwan. And I think that is very, you can enjoy your study, and you don't worry about your tuition, and you don't worry about your salary, because the salary every month you will get it. That is what I know. Yes.
Okay, thank you, Prof. maybe any question? There is Mr. Ray. He attend of this session. Please, please come to speak. Your professor, Mr. Ray. Halo. Okay, wait a minute. Silakan mungkin kalau ada pertanyaan pakai bahasa Indonesia nggak apa-apa, nanti sama Mbak Tania nanti di translate.
Ya Pak, ini pakai bahasa Indonesia saja Pak ya?
Ya nggak apa-apa, nggak apa-apa.
Jadi saya ingin saya tanyakan, apakah ada kemungkinan orang dari jurusan, kita kan jurusan lain, dari jurusan desain produk bisa masuk kayak ini Pak, kayak lintas jurusan itu apakah bisa memungkinkan atau kita harus masuk departemen sains dulu baru bisa bersama dengan Prof?
Masuk dulu ke mana departemen?
Kita kan beda jurusan kan Pak dengan departemennya Prof Lu, departemen desain produk. Untuk bekerjasama dengan Prof Lu untuk sama-sama bikin paper bareng, apakah kita bisa masuk ke departemennya Prof Lu atau kita harus masuk ke departemen yang sesuai dengan jurusan kita?
Oh, nggak masalah, tidak masalah. Beda jurusan nggak apa-apa. Itu kalau yang saya pahami ya, nggak ada
untuk
problem.
Beasiswanya apakah harus satu jurusan atau bisa jurusan lain, Pak?
Halo, tolong Tania tanyakan tolong.
Okay, Professor Long. So Ray asked if there's any chance to work together with you, even if they're not in the same department as you're in.
Of course, that is possible because the as you know, you meet like the Ren and the Aku, they are from your department, and of course they are working. They are do very well. They study in here. So I think the main problem is not your background is good. Your training in your department is very good. Under the Dr. Hendry his training, I think your training is okay. But the main problem is you need all of you the collaboration is need to not a short time. 6 months, I don't think that is enough. But about the 1 or 2 years, I think that would have the better. After our collaboration, after our co-working, I think the main outcome should be the published paper. Why? Because after published paper, we will know how is the weak point of our study, and we will know how is the future work in our study. So the paper should be a good organization for our study to know our weak point and our future work. I think co-working is no problem, but the main important is the outcome. The outcome is the first, maybe a paper. Second one, maybe we can use on the industrial. The industrial to first is in the academic, another it should be in the industrial. Industrial is the make this product to be the on the market, and in the market we can sell it and make money, I guess. That is my opinion. Thank you.
Baik, mungkin masih ada pertanyaan. Silakan. Ini ada Farhat nggak? Mbak Tania ada Farhat nggak? Oh, nggak ada. Silakan. Mungkin ada pertanyaan. Pakai bahasa Indonesia aja Mbak Tania, mungkin teman-teman malu mungkin.
Iya, bagi yang mau bertanya boleh bahasa Indonesia, nanti saya translate.
Atau Mbak Tania tanya? Ya.
Ya, Fahmi silakan.
Oke, silakan.
Okay, thank you Tania for the kesempatannya apa ya kesempatannya itu?
Opportunity.
Okay. Pardon me, Professor Lung. Let me ask a question.
Okay.
My name is Fahmirul Abdillah. I'm from Information System, Universitas Airlangga. Okay, for the future research in 2022, Professor Lung also has a paper that you will do in the future. And 2022, how much paper with or research that you will take on the future? And
you mean
maybe that is the opportunity. Yep, maybe that we can reach the opportunity for us engage. Then we can manage to the next year. We will go to them. We will go to Mr. Lung, right, like that.
Okay, maybe
that's all. Can you take my question, or
well, maybe he means about open problem, yeah, for Mr. Fahmirul to take maybe my master degree to you, or maybe internship, yeah, in your lab.
Yeah.
So you mean about the how many paper in 2022?
Yep. I thought like in 2022 is our change in UNAIR that we will go abroad to take master degree or something that we will recommend you as a goals ahead.
Okay, of course. That I think right now the because the vacancy right now everybody have used it. After vacancy finish it, I think in the end of this year, as you know, 2022, maybe we can I can go to the Indonesia, to the Surabaya, and you can also come to Taiwan. I think in 2022, that is no problem about the COVID-19. Right now, because the vacancy is not popular, is not popular. So in the 2022, yes, of course. About study, I want to say, first is my concept is focus on the soft tissue injury. So if you are interested about it, and you want to focus on it, I think that is good for when you back to Indonesia. That is good. Why? Because the people when the economic increase, I think the Indonesia right now, your salary is increase. I mean the salary, the money is you can make money better than before, and after that, the lot of the disease will come in. For example, the diabetic foot. Why? But diabetic foot is you eat better, you drink is better. So after your eating and drinking is more better than before, then diabetic foot will come in. So I think after we have I will still focus on the soft tissue injury, especially on the diabetic foot foot ulcer. So when we can focus on the as you said 2022, 2023, and then when you get the master degree or PhD degree, then you can stay stay in Taiwan, or in my opinion, that is why I tell the Professor Professor Hendry, Airlangga student is good. After you have the good training in here or in your university, your PhD can go to the United States. United States, they want to have a good student, and but right now the main important for you is not publish paper. Okay, let me explain it. Let's all of you are in Indonesia, and maybe you want to go to Taiwan, maybe you want to go to the Korea, maybe you want to go to Japan, maybe you want to go to the Canada, or you want to go to the United States or the England. But the main important is when you have the good reputation, you will get the scholarship from other country, not only Taiwan, from other country reputation. But what is the reputation? Reputation is okay. Your grade is good. You have a good skill. You have the good language. But I don't think that is enough. Why? Because the reputation is based on the everybody know it. So if you really want to go to United States, Canada, Germany, England, or other West country, I think the main important thing is publish paper. After you publish paper, and you can get the scholarship from there. For example, every summer vacation, I will visit to the United States, the UIUC, University of Illinois at Urbana and Champaign. In that school, they will give you about the 50,000 scholarship US dollar per year. I want to say it again, 50,000 US dollar per year. That is for the scholarship. And 30,000 that is for your tuition, and 20,000 is for your stipend scholarship for you. Actually, okay. Scholarship have divided two. One is for your stipend. Stipend is you can get the money every month. 20,000 per month. You can get the money. But about the 30,000 US dollar per year, that is for your tuition. That is for your tuition. So totally is 50,000 per year scholarship. So I think right now you can have a plan to be in Taiwan. But if I were you, I know all of you is the excellent, is the good. You are very smart. All of the Airlangga students is very smart. So you want to consider if one day maybe you will be the you will get a PhD in United States, in other country, not only in Taiwan, not only in Indonesia. That is what I want to hope every student can consider about it, consider about this issue, because you can do that because you are all of you are smart student. Okay, that is what I said. Thank you.
Okay, thank you so much, Professor Lung, for the insight and the advice. So maybe in the next occasions, Professor Lung can inform us about the research through Mr. Hendradi, so we could prepare it from today. Thank you, Professor.
Thank you. If you have any question, please let me know, and you can email to me and or line to me. I will always online. Professor Hendradi know it, right?
Oke, mungkin ada pertanyaan terakhir, Mbak Tania. Atau Mbak Tania mau tanya? Silakan.
Iya, saya mau tanya.
Yeah.
Professor Long, I have a question.
Okay.
Do you plan or have you ever worked on making digital products related to biomedical engineering? Because
yes,
so
yes.
far, Yes,
Yes.
so far I've only seen the physical products.
You mean the really product and the medical product I have ever met before, right?
The digital ones like applications, websites, or others. Because so far I've only seen the physical ones like insoles and shoes and all that.
You want to know the I use the okay application, you know, okay, you want to ask the shoes, the smart shoes for the pressure information respond to the smartphone, to the application, right? You want to ask that?
Yep.
Okay, actually that is the that's project is about 2 years ago, and the main important thing is the battery. The main important thing is the battery. Why? Because the pressure system need to the battery to record the data. I think right now the similar the car or motorcycle or something, electrical mobile, electrical car, that is the main important is the battery. Right now the battery development is good. So right now our electrical car is okay, is similar okay. So I want to tell you, right now our system, the main problem is the battery. We cannot keep the battery on very well every day because they need to charge. So sometimes, okay, in the first week, people buy it and back home. That is, he can charge it every day. Yes, that is good. Similar when you use your smartphone. But after 1 week or after 1 month, they will don't want to do that again because the data is always same. The response data is always same. So the consumer, the people will not charge the battery again, and they don't want to read the smartphone. Why? Because the data always the same. But after this experience, we consider maybe this project is good for the patient in the hospital. Why? Because the patient in the hospital just need to live in there at least 1 month, 1 week, and in that time, the nurse will very care about how it's different with his, for example, the exercise. When the medical doctor asks the patient need to exercise, and we didn't know it, but we can use the smart shoes to monitor their exercise, the physical exercise. So I think 2 years ago, our consumer will focus on the normal people. I don't think that is a good idea because that is not popular right now. We consider to apply this technology to use on the patient in the hospital. I think this is maybe it is good for this project. So yes, I think your question is good. Why? Because as you know, no one use that right now. So this is not unpopular. This is not popular for the smart shoes. But I think we can change the consumer, and I think that would be better in the future. Okay.
Thank you, Professor.
Thank you.
Pak Hendra, mungkin ini pertanyaan terakhir apa sudah?
Sudah cukup, udah sore.
Oh, okay.
Photo session.
Okay. Okay, the Q&A session has ended. Thank you, Professor Long, for the answers. And now we've reached almost the end of the event. So as I've mentioned before, we're in photo session right now. So if you don't mind, please kindly turn on your cameras and prepare your best smile. Yuk teman-teman, jangan malu-malu. Kita lagi mau sesi foto. Jadi kalau misalkan bisa nyalain kamera, nanti akan ya muncul wajahnya.
Yuk, nyalain kamera yuk. Boy, siap boy. Ada boynya? Ada.
Coba boy ya.
Mantap. Teman-teman, kita foto bersama Profesor Lung. Let's have a picture with Professor Lung. Yuk, kita on cam.
I want to, okay.
Please count it.
Oke. Ini udah ada lagi yang ingin open kamera. Oke, langsung saya hitung ya. Dalam hitungan 3, 1, 2, 3. Oke, pakai bahasa Inggris. Oke. On 3, 1, 2, 3. Oke. Silakan dikembalikan ke Mbak Tania.
Okay, thank you everyone for your participation, and a huge thank you to Professor Long for being with us today despite his busy schedule, and Pahendra for making this guest lecture possible. And we're also inspired and motivated. And to all participants, thank you for attending our guest lecture today. For those who are waiting for the feedback form link, the link is in the Zoom's chat box now, and you may fill it out if necessary to get a certificate. And with that being said, huge thank you to everyone who made this event possible, and we'll see you on day 2 on Guest Lecture 2021. Stay safe and healthy. We'll see you tomorrow. Bye.
Bye-bye.
Bye.
Thank you,
Thank you
Professor
very much.
Hendra. Bye-bye.
Yeah.
Bye-bye.